Hello students, this is Anjana from Computer Science Department. In the previous classes, we have discussed some of the topics related to the combinational circuit. Now let's let us see the other topics that are related to this combinational circuits. Okay. So in the previous classes, we have discussed about what are the combinational circuits and this classification and the characteristics and about the half adder circuit and the block diagram of the half adder circuit. And next one, full adder and circuit diagram of the full adder and half subtractor, and about the full subtractor, and about the decoder and the encoder we have discussed, and we have discussed about the priority encoder also. Now let us see what are the design procedure that are involved in the combinational circuits. What is the design procedure that is involved in the combinational circuits? Now let us see. Here the design procedure involves the following steps. The following steps it will involve when the design procedure involves means whenever if you are having any problem, then the design procedure is involved. So if the number of available input variables are required when the output variables are determined at that particular point of time, the design of the combination circuit design procedure will be involved. So how we are going to design just like that. Okay? Here from this we can say that the number of available input variables are required when the output variable is determined. Okay? And next one, the input and output variables are assigned at the letter symbols. The truth table that defines the required relationship between the inputs and outputs are derived such that the simplified Boolean function for each output is obtained. So that the logic diagram, from this we can draw the excuse me, from this we can draw the logical diagram here. So these are the design procedure in steps that will be involved here. Now let us see what are the design steps procedure that will be involved. Whenever the problem has started, it will having some design procedures, and if the number available at the input variables and required at the output variable is determined, and next one, the input and output variables are assigned at the letter symbols, and next one is if the truth table that defines a required relationship between the input and output whenever the input and output is derived, so the simplified Boolean function for each output is obtained. So the logic diagram is drawn like this. So this is a binary or parallel adder. See, this is if you are going to add the multiple, if you are going to perform the multiple tasks, this is the one of the best option for us to perform the addition. By using the binary or parallel adder, we are going to perform the addition simultaneously. Here we are having, this is some of the example that we are having 4 full adder circuits. Okay, how we have designed this design procedure? Here we have taken the 4 full adder circuits here. Here for the full adder we are having the 2 inputs A0, B0. This is the first full adder, and this is the second full adder. Here it is taking 2 inputs A1, B1. This is third full adder. It is having another 2 inputs, that is A2, B2, and this is up to N full adders. We have taken this AN up to BN. Okay. So for this automatically for this all full adders the carry is common. So we have taken the carry here, carry in and carry out just like that, and this is the sum. What are the sum that we will get here, that we are going to place here. Okay. This is a logical diagram for the binary or parallel adder. See, if it is a binary or a parallel subtractor, here whatever the difference that we'll get is here by giving the input, by giving the NOT gate to the input V, we can get the parallel subtractor or binary subtractor. Okay, here if you have observed, this is the first full adder, and this is second full adder, and this is third full adder, and this is the fourth, this is the nth full adder. Up to here we are having so many full adders here. By combining these full adders, by giving the inputs here, we can get the subtract, definitely we will get the output of the, that is the difference between the two outputs, two inputs. So here this is the result that we are going to get here. Okay, see, if you have taken this encoder, so here the encoder is having 2 power n inputs and n data outputs. Okay, so this is the if you have observed, this is a block diagram for the digital circuit that performs the inverse operation of a decoder. We can say that one as a encoder. So an encoder has a 2 power n input lines and an output lines. So in encoder, the output line generate the binary code corresponding to the input value. Whatever the input value that we have generated, based upon the input value, we are going to give the binary code corresponding to the input value. So here we are having the 2 power inputs. From that we will get the n data outputs. Okay. So this is the truth table of the octal to the binary encoder. So if you have observed this one binary encoder, if we are having 3 inputs, so from these 3 inputs, we are having the possible number of outputs is 8. That is D0, D1, D2, D3, D4, D5. In the previous classes, we have discussed the encoder with 2 inputs. This is an encoder with 3 inputs. So if you have observed that the truth table of octal to binary encoder, so see here, if you are here, it is taking the 3 inputs here, so that we will get the 8 possible combinations. If a value is 0, b value is 0, c value is 0, that is in these cases 3 value is 0, the value is, it will at d0 we have to keep the value 1, and the rest of the remaining things all should be placed with 0. Okay, and if the a value is 0, b value is 0, and c value is 1, so the d1 value is, at the place of d1 will kept 1, and the rest of the all should be kept as 0. If a value is 0, b value is 1, and c value is 0, at the place d2 will keep the value 1, and the rest of the value will become 0. Next one, if the a value is 1, a value is 0, b value is 1, and c value is 1, that is the value is 3. So at the place 3 we will keep the value 1, and the rest of the thing will become 0. Next one, if the at 100, that is the value will become 4. 100 is the value is 4. So at the place 4 we will keep the value 1, and remaining rest of the places we will keep the value 0. And next one, 101, that is the value 5. If it is 101, we can binary to decimal combination, we have already discussed about this. I think now we should not discuss at this time. So that is 101. So at the 5th place we will place 1, and the rest of the values will become 0. And here 110, that is 6. The value is 6. So at D6 will keep the value 1 here, and the rest of the places will become 0. Okay. And the next one, 111, that is value of that is 111 is 7. So at the place 7, we'll keep the value 1 here, and the rest of the all things will become 0. See, this is the diagram for that how what is the octal to binary encoder here up to D0 to D7. Up to D0 to D7, we are having the after D0 to D7, we are having this possible number of outputs. So from that we are taking the OR gate. So here D4, D5, D6, D7 we have taken, and next at B, D2, D3, D6, D7 we have taken, and next at C, D1, D3, D5, D7 we have taken. Okay. So now we have taken, we have seen about the decoder with multiple encoder with multiple input. Now let us see about the decoder with the multiple input. Okay. A decoder is a with multiple input and multiple output logic circuit which converts the coded input into the coded outputs, where the input and output codes are different. Here both the input and output codes are different. The input code generally has a fewer bits than the output code, so each input code word produces a different output code word. So here basically a decoder is a multiple input and multiple output logic circuit. Here it converts the what it do, it will converts the coded inputs, that is what are the input that we have performed the coding, then it will convert the code input into the code output. Okay, where the input and output codes are different. Here there is no relationship between the input and output codes. Here both the input and output codes are different. And next one, the input code generally has a fewer bits than the output code. So what are the bits that you are having the input code? Input code should be an input code we are having the less inputs when compared with the output. Okay. And next one, each input code word produces a different output code word. So what are the input code? If we have provided the different input code word, from that if we have, it will definitely provide the different output code word. So a decoder is a multiple input and multiple output logic circuit which converts the coded input into the coded outputs, where the input and output codes are different. Here the input code generally has a fewer bits than the output code, such that the each input code or produces the different output code word. Okay, these are the decoders with the multiple input and multiple output logic circuits. Go for the next slide. See, this is the general structure of a decoder. So here this decoder having n data inputs, and here this will, when compared, we have already said that when compared with the input it is having the less number of when compared with the outputs it is having the less number of inputs. That is, it is having, if it is having n inputs, then the possible number of output will become 2 power n. So see, if you have, so we can say it as a n is to 2 power n decoder. See, these are the n inputs. Here we will enable the inputs. These are the possible number of outputs we'll get. This is a decoder. Okay, n is to 2 power n means n inputs and 2 power n inputs, 2 power n outputs. Okay, so usually a decoder is provided with the enable inputs to activate the decoded output based upon the data inputs. When any one enable input is unasserted, all outputs of the decoder are disabled. So whatever the inputs that we have taken, so all should be disabled at a time. Why? Because usually whenever you are using a decoder is provided with the enable inputs. So whenever you have taken the decoder, it should be the inputs always should be enabled. So it should be activated to decode outputs based upon the data inputs. So if you want to disable, then based upon that's user choice, we can easily enable and easily disable. So with the enabled inputs, whatever have taken the enabled inputs to activate the decoded outputs, based upon the data inputs, whatever the data inputs, then we can enable the inputs to activate the decoded output. Okay. When anyone enable the input is unasserted, all the output decoders are disabled. Okay. So this is the general structure of a decoder. For a decoder, we are having the n data inputs. Here, these are the possible number of output combination. So in the previous slide itself, we have discussed when compared with the number of inputs, we are having the more possible number of outputs. So we can say it as a n is to 2 power n decoder. So usually a decoder is provided with enable inputs to activate the decode output based upon the data input, and when one enable input is unasserted, all the outputs of the decoder are disabled. So this is the general structure of a decoder. Then the difference between the multiple decoder and binary decoder is mm, a decoder which has n bit binary input code and a one activated output of 2 power n output code is called a binary decoder. So a binary decoder is used when it is necessary to activate the exactly one of 2 power n output based on n bit input value. Okay. So if you have observed, this is the truth table for the 2 to 4 decoder. So this is enabled bit. If it is 0, then the value should be of a and b is nothing we will have. So the output is of 0 0 0 0. And if you have taken these inputs, then it will become all the enable bits will become 1. So if it is 0 0, the y0 value at the 0th position, the value will become 1. If it is 0 1, the value is 1. No, the 0 1 అంటే ఎంత బైనరీ నెంబర్ మన కన్వర్షన్స్ తెలుసు కాబట్టి 0 1 అంటే 1. సో at the place y1 we have to keep the value 1, and next one 1 0 means the value 2, so that at the place 2 we have to keep the value 1, and next one at the 1 1 1 1 means 0 1 1, that is the value will become 3. So at the value 3 we'll place the value 1. So up to see why we have taken this, and why? Because here the enable bit is 0, because here we does not provide any input value here. So it automatically the enabled bit will become 0. So if you have taken any input, automatically the enable bit will become 1. Okay. Here if it is 0 0, at 0th value the value this value become 1. If it is 0 1, at first value the value becomes 1. If it is 1 0, at second value the value becomes 1, and if it is 1 1, at the third value the value becomes 1. These are the possible number of combinations that will get uh, in the form of the 2 to 4 decoder. Okay. Here that is 2 to 4, that is binary decoder truth table. This is the general structure of the n into 2 power n. That is, if you have taken 2 inputs, then the output is 2 power 2, that is 4 output we will get. Okay. This is about a multiple decoder and multiple encoder we have discussed in this class. So in the next class we are going to continue this. Okay. Next class we will continue the next these topics 2 to 4 decoder circuit and truth table for 3 to 8 decoder and logic diagram. We'll discuss it in the next class.